All right, so this is the review for Chapter 1 of McDougall-Littell Geometry. So remember to study your vocab for page 2 in the book. There'll be a vocab section that I'm not covering in the review. All right, in questions 1 through 3, you're predicting the next 3 numbers in the series. And so if we look -2 to 2, that is a difference of 4. 2 to 6, it's a difference of 4. 6 to 10, difference of 4. So we're going to go 4 3 more times. So we're going to have 10 plus 4, which is 14. 14 plus 4, 18. 18 plus 4 will be 22. Next set of numbers, going from -5 to -2, which is a difference of 3. To -2 to 4, it's a difference of 6. And 4 to 13 is a difference of 9. So we're going to assume that pattern is just going multiples of 3. So 12, 15, 18. So 12 plus 13 is going to be 25. 25 plus 15 is 40. 40 plus 15 is 58. All right, next set, 1, -1/2, 1/4, -1/8. So we're changing signs. So that would give us the idea that we're multiplying by a negative, and everything is getting smaller in the denominator, because 1 would be 1 over 1. So then it goes from 1 to 2 to 4 to 8. So the denominator is doubling every time. Or we're multiplying by -1/2 is what's happening here. So you go to the next number, -1/8 times -1/2 will be positive 1/16. 1/16 times -1/2 is going to be negative 1 over 32. And -1/32 times -1/2 is going to give us a positive 1/64. So 1/16, -1/32, positive 1/64. All right, 4 through 7, using the diagram to name the figures. All right, 3 collinear points. Collinear means on the same line. So any group that we got 3 on the same line, got 2 different groups, ADB or CDE. So A, D, and B, or C, D, and E. Either one of those groups would work for 3 collinear points. 3 non-collinear points. So 3 points that are not on the same line. Right, so you got a wide variety of choices. Just make sure that you don't have A, D, and B as the group, or C, D, and E. So any combination of anything else, I'm just going to go H, A, C. So those are definitely 3 that are not on the same line. All right, 4 non-coplanar points. So non-coplanar, saying not on the same plane, because coplanar is on the same plane. So H, A, D, and B, those 4 are on the plane, so they're all coplanar. C is off the plane and E is off the plane because they're on a line that's going through the plane. So as long as I include C or E, or both of those with points from the plane, I'll have a non-coplanar set of points. So I'm going to go with H, A, C, or E, and C. Then 2 intersecting lines. There's only 2 lines in the picture. So you got line CE and line AB. Remember, when you're naming a line, you put the little line symbol over the 2 letters. All right, next one, finding the length of a segment. So lengths of segments uses the distance formula. The square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So for AB, the points we're using are -2, 3, and 1, 1. So working 8 down here. So then for AB, we have the square root of the two x's. So 1 minus -2 squared plus the difference in the y's, 1 minus 3 squared. So 1 minus -2 will be a double negative, so that becomes positive. 1 plus 2 will be 3 squared. 1 minus 3 will be -2 squared. If I square 3, I get 9. -2 squared will be 4. And so the square root of 9 plus 4, or the square root of 13, which is a prime number, doesn't have a perfect square root and doesn't simplify, so we leave it as a square root of 13. Number 9, we're looking at the length of CD. So point C, -4, -3, and point D, 3, 4. So looking into the distance formula, difference of the x's, so 3 minus -4 squared, plus the difference in the y's, 4 minus -3 squared. So 3 minus -4 becomes plus 4, or 7 squared. 4 minus -3, double negative, becomes 4 plus 3, plus 7 squared. So it's square root of 49 plus 49, which becomes the square root of 98. And a big number like that, we want to see if we can simplify it if we can, which 98 is the same thing as 49 times 2. 49 has a square root, which would be 7, so that 7 comes out, and the 2 is going to stay underneath there. So 7 square roots of 2 will be the answer for that one. All right, using the diagram, find the measure of each angle. So if we look at where each one of these rays ends up, ray AE ends up at 0, AC ends up at 80, AB is at 120, AF is between 150 and 160, so we're going to estimate 155, and D is at 180. So angle EAB is going from 0 to 120, so the absolute value of 120 minus 0, 120 degrees, because the measure of an angle is the absolute value of the difference of the values for the two rays. So CAF, angle CAF starts at C at 80 and goes to F at 155. So that's 155 minus 80 is going to give us 75 degrees. Then angle BAD goes from 120 to 180 from B to D, and so that's 180 minus 120, which is 60 degrees. All right, 13 through 15, we're still using that same diagram and just determining what type of angle, or we're classifying the angles. Angle EAB, 120 degrees, so that's more than 90 but less than 180, which makes it obtuse. All right, angle CAF, which was the same angle from 11, which was 75 degrees. So 75 degrees is less than 90 degrees, more than 0. So that classifies it as acute. Number 15, angle EAD. So from E to A to D, right, 180 degrees, 0 to a 180, then a 180 degree angle. is a straight angle. All right, 16 through 18, we're finding the midpoint for the segments with the given endpoints. Got the midpoint formula, which is just taking the x's, adding them together, and dividing by 2 to get the x coordinate. Y is added together, divided by 2 to get the y coordinate of the midpoint. So for 16, our midpoint is going to be the x's added together, 0 plus 0 over 2, and the y's added together, 0 plus negative 12 divided by 2. So the midpoint is going to be 0 over 2, negative 12 over 2. 0 over 2 is 0, negative 12 over 2, negative 6. 0, negative 6. 17, same process. Midpoint is going to be the x's added together, 2 plus negative 2 over 2, and 9 plus negative 1 over 2. So that's going to give me 2 plus negative 2 is 0 over 2. 9 plus 1, 8 over 2. So my midpoint is going to be 0, 4. All right, 18. Got EF. Same process again. Midpoint. Add the x's. So 9 plus negative 3 over 2. And add the y's. Negative 15 plus negative 3 over 2. 9 plus negative 3 is going to be 6 over 2. Negative 15 plus negative 3, negative 18 over 2. Divide them by 2. I get 3 and negative 9 for the midpoint. All right. Moving on. 19 and 20. It says ray EF is the angle bisector of angle TEA. Find the two angle measures not given in the diagram. All right, so if EF is an angle bisector, that's saying it's splitting the angle in half or creating two congruent angles out of the one angle. Number 19, we got the arc here, which tells us the 74 degrees is representative of the entire angle TEA, not just this part of FEA. So we've got the measure of the whole angle. So the two angles we've got to figure out is TEF and FEA. So since EF, ray EF is a angle bisector, that means each one of those angles is half of the original angle, or the measure of angle TEF is going to be half of 74. Which is 37 degrees. And since it's a bisector, those two angles are going to be congruent, TEF and FEA. So if TEF is 37 degrees, FEA also 37 degrees. All right, number 20. Notice this case, it doesn't have the arc going around here, so this 29 degrees is only for angle FEA. And so the angles we've got to figure out are TEF and TEA, the whole big angle. So just like we stated before, measure of angle TEF should be the same as the measure of angle FEA. FEA is 29 degrees, so TEF is 29 degrees. And the measure of angle TEA would just be those two angles added together, 29 degrees plus 29 degrees, or 29 degrees times 2, 58 degrees. All right, 21 and 22, still building on the concept of angle bisectors. It says BD is a bisects angle ABC, find the value of x. So if BD is a bisector, then the two resulting angles are congruent. So to solve for x, we're going to set the two angle measures equal to each other. Or 2x plus 24 is going to equal 3x minus 12. And just solve for x. So subtract 3x. So negative x plus 24 equals negative 12. Move the 24 over by subtracting. Negative x is going to equal negative 36. And divide by negative 1 to get that to be positive. So x is 36. 22, same concept. BD is a bisector. So angle ABD and angle DBC should be equal to each other. Or 18 minus x should equal 26 minus 3x. So solve for x. Add 3x to both sides. So the 18 plus 2x equals 26. Subtract the 18. It's going to give us 2x equals 8. And divide by 2. Our x value is going to be 4. All right, question 23 through 25. Use the diagram to solve for the missing angle measures. All right, in order to do this, you have to recognize vertical angles and linear pairs. Remember that the vertical angles are going to be the same. Linear pairs are going to add up to equal 180 degrees. So it tells us the measure of angle 1 is 44 degrees. What's the measure of angle 3? Well, angle 1 and angle 3 straight across from each other. This side of angle 1 makes the side of 3, and the other side of 1 makes the other side of 3. So those fit the category of vertical angles, and vertical angles are the same. So if 1 is 44, then 3 is also 44. All right, next option, angle 2 is 78 degrees. What's the measure of angle 1? So in this case, we're looking at angle 1 and angle 2, which are side by side with their non-common sides, creating a straight line or a set of opposite rays. So that makes them a linear pair, and the angles of a linear pair have to add up to equal 180. So the measure of angle 1 plus the measure of angle 2 should equal 180, or the measure of angle 1 plus 78 equals 180. Subtract 78 from both sides. The measure of angle 1 would be 102 degrees. 102. And the measure of angle 4, it tells us, for 25 is 33 degrees. So 4 is 33 degrees. What's the measure of angle 2? So this side of angle 4 makes the side of angle 2. The other side of angle 4 makes the other side of 2. So those are straight across from each other, making them vertical angles. And the vertical angles have to be the same. So if angle 4 is 33, angle 2 is also 33 degrees. All right, 26 through 28, we're just labeling these officially as linear pairs or vertical angles. So angle 1 and angle 3, as we discussed in number 23, they're straight across from each other. Each side makes the side of the other angle. So that makes those vertical angles. '27, angle 2 and angle 1, those were side by side, forming a straight line. So those are a linear pair. 28, angle 4 and angle 2. So those are straight across from each other. Each side makes a side of the other angle. So those are a set of vertical angles. All right, 29 and 30, solving for the variables, which if we look at the example here, we have two terms with x's, two terms with y's. The terms with x's are on one side, where they are side by side, forming a straight line. So they are a set of linear pair angles, and linear pairs have to add up to 180. So to solve for x, we simply say 2x plus 10 plus 4x plus 20 equals 180 degrees. The two angles added together equal 180. So now solve for x. 2x and 4x is 6x. 10 plus 20 plus 30 equals 180. Then subtract 30. 6x equals 150. And divide by 6. X is going to equal 25. All right. Now, our y's on the other side are also part of a linear pair, side by side, creating a straight line. So, going to work them the same way. Set them equal, or add them together and set them equal to 180. So 5y minus 25 plus 2y plus 2 equals 180. Add the y's together, that's going to give us 7y. Negative 25 plus 2 minus 23 equals 180. Add 23 to both sides. We get 7y equals 203. And divide by the 7 on both sides. That's going to give us y is equal to 29. All right, next example 30. Same basic setup. You got two angles with x's that make a linear pair on the left, two angles with y's that make a linear pair on the right. So set the 3x plus 1 plus 5x minus 5 equals 180. Those two x angles added together equaling 180 because they're a linear pair. So 3x plus 5x is 8x. 1 minus 5 minus 4 equals 180. Add the 4 to both sides. 8x equals 184. And then divide by 8. And we're going to get x equals 23. And then same process for the y side. 2y minus 10 plus y plus 10 is going to equal 180 because they're a linear pair as well. 2y plus y is 3y. Negative 10 plus 10 is 0, so they disappear. So we have 3y equals 180, divided by 3, and y equals 60. On the test, it's possible that I might give you one where the angles with the x's are vertical angles, and the y's are vertical angles. So instead of adding them together to equal 180, we would have to just set the angles equal to each other and solve for x or y. All right, last portion here, finding the areas of the figures described. So 31 is a triangle with a height of 2.5 centimeters and a base of 8 centimeters. So area formula for a triangle is 1/2 the base times the height. So that's going to be 1/2 of the base, which is 8 centimeters, times the height, which is 2.5 centimeters. So 1/2 times 8 would be 4, and 4 times 2.5 is going to give us 10. And it's centimeters squared. Making sure we put our units, otherwise we're partially wrong because we don't tell exactly how that's measured. All right, 32, a square with a side length of 7 feet. So area of a square is the side length squared. And the side length is 7 feet. So we square that to get the area of a square. 49 feet squared. And then 33, a circle with a radius of 4. Area of a circle is pi times the radius squared. So it's going to give us pi times 4 yards squared. Or pi times 4 squared is 16 yards squared. Or rewrite that as 16 pi yards squared, which we could leave it there. Some examples may ask you to use 3.14 for pi. Go ahead and give a numeric value to that answer. Which, if that's the case, then we would do 16 times 3.14 yards squared, which 16 times 3.14 would be 50.24 yards squared. So for this example, 16 pi yards squared would be good enough, but if it asks you to use 3.14, then you multiply the 16 by 3.14 to give you 50.24. All right, so that covers the review for Chapter 1. Study hard, be ready to do well.